been developing in Conservación Amazónica and Servir Amazonia. We are going to explain our advances in the topic of monitoring logging routes and selective logging using deep learning and satellite imagery. Uh, the first, we are going to detail these concepts. The logging roads are infrastructures that allow the circulation of people and car transports in forests, and selective logging consists of the extraction of individual trees of certain species of high value. In We can see in the image the differences between these types, and these activities are developed under different conditions and under different scales, and creating a pattern. The current image show the spatial pattern are the interrelationship between the various activities occurring in the Amazon. By analyzing these patterns, we can see how knowing the presence of a row can help detected logins, for example, and or how verify the presence of a camp could help the detected selective login, for example. We are going to look at the main changes in the detection of error roads and selective logging. First, the presence of clouds throughout the year. The open source image only allow the detection of high impact selective logging. The possible moderate amount of false positives of selective logging case, like deep trees, clearings, landslides, etc. Selective logging has as a spectral similarity with the other covers, for example, links, sandbanks, backgrounds, maybe logging routes. And the logging routes are sometimes discontinued and partially visible, and the visual interpretation of the selective logins is hard. It's a mixed class. Finally, there is not historical datasets or guidelines for collecting this data. In our past experience with the detection of selective logging and logging routes, the first step was use machine learning. For example, random forest in this case. Um, we we used points of training data, and these were the results. The first step was the implementation of the random forest model using pixel by pixel classification. As can be seen, the results were not so good, and this is another example of our results using Sentinel-2 image. We then decide to try other algorithms, such as neural networks, starting with a simple CNN neural network. And my colleague Osmar will explain in more detail this part and the path we follow with deep learning.
Hello, everyone. Thank you. Thank you very much, Marvin, for the introduction. Yes, as you said, we first started with manually digitizing selective logging activities, storing them as points. Then we transitioned to a machine learning approach, classifying individual pixels of selective logging. Then, when we saw that the results were promising, we moved on to just a simple multi-layer perceptron, just to check out if including deep learning, it's better. And we saw that the results were promising. After the multi-layer perceptron, we transitioned to a simple convolutional neural network with two hidden layers. And you can see on the screen the results of applying just a simple model into a planet NIFI image. Next one, please, Marvin. Now we want to present our work, which consists on applying a much more state-of-the-art architecture, and our workflow consists on these 6 steps. We first manually hand drew the login, selective login activities and login roads, and we call this our benchmark dataset. The second step was exporting our benchmark dataset into a TF record format, so we can train a deep learning model with the libraries of TensorFlow and Keras, and we stored our patches on the Google Cloud Storage. Then we train the model and we store the model as well on the Google Cloud Storage. We'll be talking a bit more about these steps, right? So our model, we EEFI the model so it's readable by Earth Engine, and we deployed the model to the AI platform. Then on the final step, we were able to visualize our results in the same Google Earth Engine client. Next one, please. So this was our first benchmark of the selected login dataset. We have like almost multiplied by 2 the amount of patches that we manually hand digitized before. We used to have less than 300 patches. Now we have over 800 patches and over 40 different satellite images from August 2020 until October 2022. One thing that we have to remember is that SkySat images have a very high resolution of 0.5 meters. And SkySat has 4 bands, the blue, green, red, and near infrared. Or images, since they are kind of like radiometrically inconsistent, SkySat before March of 2021 were offered as a different product with a different uh, pixel values. We normalize those values. So it's much more consistent this way. And as additional predictors, we included the NDVI, the NDWVI, the BNDVI, and 2 more, right? So we split our data or polygons into 70% training, 20% validation, and 10% testing. And for the digitalization, we use QGIS with the Earth Engine plugin, since our SkySat images are already present in the Google Earth Engine platform. Next one, please. This is for the selective plugin dataset. Next slide, please. Okay, and for the login roads, we had a different data set. We used, for this specific case, Sentinel-2 images, and same as the SkySat images, we normalized them, but in this case, we did not include spectral indices. In this case, we have over 600 roads that were manually hand digitized as well, and we used the same software. Next one, please. Okay, so in this slide, we can see the detail of the SkySat images and the comparison of an RGB SkySat image and an near infrared red and blue near infrared red and green band combination. Next one. And we can see here the digitalization of the login roads. Next one. So regarding our patch generation in TensorFlow, we transformed or we exported our polygons with a patch size of 64 by 64 in the case of selective login activities and 128 by 128 in the case of login roads, because they are much bigger than the login activities. And we used a for loop to export all of our patches into a readable format, which is a TF record. One thing that we have to notice is that we applied data augmentation for the selective login dataset, not for the login roads dataset. Next one, please. And on this slide, we can see that our patches or TF records were exported into our own bucket together with our model. And each TF record preserved the ID of the SkySat image and the Sentinel-2 image as well. Both datasets were exported into different buckets. Yes. Next one, please. And we can see the model architecture. In this case, we use the UNet model, which shown really good results that we will see later. Next one, please. Okay, so for training parameters, in the case of the selective login dataset and the login roads dataset, we use different batch sizes and different number of epochs. In the case of login roads, we use 60, whereas in the case of selective login, we use 40. We use the same Adam, the same optimizer. And one thing that is important is that we use the learning rate, an initial learning rate with an exponential decay, because we noticed that with our data set, the model tended to overfit really quickly, so we had to control this learning rate. And for the metrics, we used the same metrics, which were the loss, the accuracy, the intersection over union, and the dice coefficient. And again, during the training, we performed data augmentation only on the selective login datasets, which consisted on random flips, random rotation, and transposes. We also created model checkpoints to save best, uh, best the best performance of the model. Next one, please. And we can see the history of the training with selective login dataset. We used to train many models before, but this one so far has been the best one, and we can finally see that the model converged. Next one, please. And this happens the same with the login roads dataset. The model does converges as well. Next one, please. And in this table, we can see the results of testing the model and applying the model to the different data sets that we have, the training, the validation, and the testing data set on the selective login patches. We can see that the model has a kind of a slight overfit, but it's almost not noticeable. Next one, please. And the results are really similar with the login roads model. But in this case, the login roads model show a much more a higher accuracy. Yes. Next one, please. And here we can see some of the results of applying our model to a SkySat image. And we can see that our code consists on applying the deep learning model in the same code editor, and then uh, automatically the model, not the model, but we use functions to vectorize these results and eliminating the false positives, which are pretty small. And Marvin, can you access the link? Because we have prepared a small Google Earth Engine app just to show you guys the application of the model. I'll paste the link on the chat. You guys can see this GE app that we have prepared. Okay, I'll share my screen. Okay, can you guys see my screen?
Yes, we can see.
Yeah, nice. So we have created this small Google Earth Engine app to show you guys the results of applying our model on two SkySat images that the model has not yet seen. So we will first start by the second one. And pressing this button, we can visualize the image. We can notice that it has a very high resolution, and we can easily see the gaps present in the forest, which this is selective logging activity, and it's always next to a logging road. And then we can click the next button, and we can, we are not applying the model in real time. The results of the model have already been exported. We are just loading these results of the exported, that the model exported. And we can see that the results are the best ones we have gotten so far. And by clicking on this checkbox, we can filter out the false positives that we might have. We just have to wait a few seconds. But anyway, this is the application of the model on the Google Earth Engine app that we have designed, and we will be uploading some more of these results on this app. And I will share my other screen. Yes, and here we can see the results of applying the different model that had the same architecture, but that trained on a different data set. We have an incoming Sentinel-2 image, and the model automatically segments the login roads. And we can vectorize the results applying an skeletonization algorithm developed by Jank. I can show you guys the application of this second model. Okay. Okay, so this is a Sentinel-2 image, and we'll be loading the results right now. For example, we will zoom in into this part of the image, and we can easily see login roads right here. And if we see more detailed, we can see that there are some really small patches surrounding the login roads, which this is selective login activity. Let me load it again. Okay, and we will load right now the predictions, right? And here we can see that the model does a good job segmenting the login roads, right? And by applying the skeletonization algorithm, we only have a line of pixels that we can easily vectorize and having a line in a shapefile format. On the red color, you can see the outputs of the model. And with the blue, we can see the skeletonization algorithm that we can share with you guys if you guys want to. And just to finish our presentation, we have some conclusions that the model, in the case of the selective login model that we have trained, it's the best one we have gotten so far. And so far, the model, we can see that it's not perfect because it contains false positives, but it shows that by increasing our data size, we can have much better results. We need as well more variability with the SkySat images because these images do not have a perfect geometric quality. They are sometimes kind of noisy, and sometimes these images can get saturated. And as well, weather conditions do affect the accuracy of the model. And one thing that we can include, we can complement these two models by including an image of distances from the login roads model as an additional predictor for the selective login model. In this way, we can easily remove the false positives that are really far away from the login road. And this concludes our presentation. Any recommendation is welcome, and thank you very much.
Really great. That's fantastic. I have a big list of questions. I think that was just a stellar presentation. I want to say first off, like you guys could talk probably for like 3 hours about all the different iterations you've done. So like, if you ever want to come do another presentation on something really hyper focused too, I think there's a lot to learn, a lot to mine. So thank you so much for that. Are there general questions out to the audience? I have a first question, and I'm not going to eat up the entire time because you know me, I will. Um, the data augmentation approach, like the shaky pixel, flipping rotations, did you do a test ahead of time to see how many looks you actually needed to boost up that population, and sort of the rationale as to why going down this approach for doing those flips and rotations? Because it seems like it's really valuable, but do you have a sense as to maybe the other folks who are going to be wanting to maybe try this out, some good lessons learned about those data science prep work that goes into the model feed?
In our case, we perform data meditation because our data set is not that big. So, and because as well, when we see a fallen tree, we notice that it has a certain direction, right? So, by we can, in theory, we can synthesize more data by creating data augmentation. But no, we did not compare the performance of the model with and without data augmentation.
Yeah, I know. Jack Kilbride gave a presentation on the near real-time deforestation, the work that's going in Mekong a while back, and talked about the flipping pixels. And it's cool to see that you guys are really implementing this in a full workflow, because what you brought up, not having enough quality data often is a huge challenge for deep learning models. So this is a good workaround, right? Any other questions out on the line? Feel free to just raise your hand or hop on.
Yes, and digitizing this data is a complete nightmare, because when we zoom in the logging activities, we can notice that it's not a pure class. It's actually kind of a mixed class, because it contains spectral data from the leaves around the gap. It contains data from the chips that when you apply a chainsaw to a tree, you remove chips, and this has a strong spectral response. So digitizing this data to have a strong confidence, it was really hard.
I'd imagine that was a huge time effort, looking at how many points and all the digitizing required. Let's see here. Phil, go right ahead, Ollie.
Okay. I wanted to ask about the data choice that you use. Like you mentioned that you use SkySat for the selective logging and then Sentinel-2 for the logging routes, right?
Yes.
Is there any specific reason like why you use like different data source other than use the same image that you use for the training?
It's because
Thank
we
you.
are. Sorry, did not want to spoil this, but we are planning an upcoming service for our organization that provides logging roads on a bigger scale. That's why we use Sentinel-2 image, because they have a bigger footprint. We can scale up or work more. And SkySat, they are really small. They only have a size of like 6 kilometers of width and 11 kilometers of height. So we are not analyzing much of the terrain using SkySat. But yes, we can actually train a model just to detect roads on the SkySat. But I think it's much more viable with Sentinel-2, because these activities are easily seen from the space with Sentinel-2. But it could be to detect some of the roads that are well hidden under the canopy of the forest.
Osmar, it's true that, just to add to your presentation, that also SkySat is better to use to detect selective logging, comparing with Sentinel-2, which is better for roads in general, right? That's one the beauty of the SkySat, the resolution that allows you to see better, or at least confirm if it's now a landslide or a hurricane wind that destroyed a lot of trees around, right? It's the
Yes.
SkySat also basically that plays that role.
Yes, the thing with SkySat is that they are very helpful to discriminate between uh, true selective logging cases and false positives that might be, for example, landslides, as you mentioned. And we, this SkySat allow us to detect uh, the selective logging that has a lower impact on the forest as well, whereas Sentinel-2 images might help detecting selective logging, but on a higher intensity, even in a medium intensity as well. That's why we use the SkySat for, for training this model. But have plans for using Sentinel-2, but in this case with machine learning to detect selective logging activities. Yes, we have plans for that. It will be an upcoming service.
That's wonderful. Any more general questions out? Well, I have. Oh, go ahead, Biplav.
Yeah, great presentation, Osmar. I was wondering how are you running this model operationally? And that's first question. And the other question is like, as the new images comes in, are you also training? You're taking the existing weight and training your model, or yeah, can you explain a little bit on the operational phase?
Can you repeat the first question, please?
Uh, how are you hosting this model? I see you using
Hosting.
Earth Engine and everything, but with the new data sets coming in, are you retraining your model? You said you are saving weight, so how does that whole processing working on your end?
Yeah, the model right now is hosted on the AI platform, but we have seen that they are charging more us now, like $2 per day. And yeah, so we had to stop the AI platform API. Uh, but yeah, so far it's hosted there. But since we now have access to the Socrates, I think Vanessa knows about this. We are planning to uh, translate our model to that server and applying or having the results right there. And regarding to the second question, yes, when an upcoming image that contains selective logging activities arrives, we will be applying the model on the image, and the good results, the good segmentation, will be added as an additional training data set. Thank you.
Mm-hmm.
I was just going to hop in real quick on the model setup and hosting and the costing, all those components. I know we had talked with Nick quite a while back about creating some sort of flagship services that where a model could be hosted using the resources on Tensor Hub. And that was a conversation that we had kind of explored with different publications that we had done in the past on some of these works, but we haven't really circled back on it. So as you guys are exploring what that path could look like, maybe we want to toss that in too as, hey, this is could be a really useful opportunity to explore how this model could be hosted, and other people can use it also, that way if other severe hubs wanted to grab it, they wouldn't have to build it all the way from scratch as well. So just put that out there to be thinking about. Any other major questions? I have a huge list, but I'm gonna just follow up with you guys on on email because this is really cool. Any other major questions?